Alright, let us look at a question from the chapter Areas Related to Circles. In figure 11.12, arcs have been drawn with radii 14 centimeters each and with centers P, Q, and R. Find the area of the shaded region. Let us first try to understand the figure. First, we observe that PQR is a triangle. Second, we notice that the radius of each arc has been given as 14 centimeters, which means this distance and this distance is 14 centimeters. These two are 14 each, and so are these two distances. The second thing we notice is the shaded region consists only of three circular sectors formed at the three vertices. The three angles at the vertices need not be equal. So let us call the angle at P as theta 1. Let's say angle P is theta 1, angle Q theta 2, and angle R as theta 3. Now since each of these are sectors, we know sector area is given by pi r square theta over 360. So the sum of the areas of these three sectors at the three vertices would be pi r square theta 1 by 360 plus pi r square theta 2 by 360 plus pi r square theta 3 by 360. Now we can take pi r square by 360 common, which leaves us with theta 1 plus theta 2 plus theta 3. This becomes the shaded area. In the numerical, we have been told that r is equal to 14 centimeters in each of these circular sectors, but the angles have not been given. So here we resort to the angle sum property of the triangle, which says the sum of the angles of a triangle add up to 180 degrees. So let's substitute the numbers. Let's take 22 over 7 for pi times 14 times 14 over 360, and the sum of theta 1 plus theta 2 plus theta 3 is 180 degrees. So 7 cancels twice and this goes twice, and we can cancel 2 11s are 22. So if we take this product, this is 22 times 14, we get 308 centimeters squared, and that is the final area of the shaded portion. Now let us look at another question which is similar, but in this case we have a quadrilateral. Let's read the question. In figure 11.13, arcs have been drawn of radius 21 centimeters each with vertices A, B, C and D of quadrilateral ABCD as centers. Find the area of the shaded region. Now, we are told ABCD is a quadrilateral, but this quadrilateral need not be regular, which means these angles need not be 90 degrees. Although the figure appears as a square, but there is no reason why you should take it as a square because the question doesn't mention so. So again we will assume that each angle is different, and we say let angle A be theta 1, angle B theta 2, angle C theta 3 and angle D theta 4. Now the radii of these sectors are given to us, each of which is 21 centimeters. So all we need to do is find out the individual areas of each sector in terms of theta 1, theta 2, theta 3 and theta 4, sum them up, and we know that in a quadrilateral the sum of the angles is equal to 360 degrees, which is the angle sum property of quadrilaterals. We will use that and then find out the shaded area. So we say the shaded area is equal to pi r square theta 1 plus theta 2 plus theta 3 plus theta 4 all divided by 360. So now let's plug in the numbers. Pi is 22 over 7, radius is 21 times 21 over 360, and this becomes 360. And the reason we write is angle sum property of quadrilaterals. So the 360s get cancelled, 7 3s are 21, and if you take the product, this is 66 times 21, and that comes to 1386 square centimeters, and that is the final answer.